Let's look at our systems of equations. So our systems of equations are a set of two or more equations that involve the same variables. So we're going to be looking at two equations with an x and a y, and we're going to be able to figure out what numbers those x and y's are. So that's what the solution is. The solution of the system of equations is the coordinate point. It's a point, it's an x and a y value, at which the two lines meet or intersect. I can't spell. Intersect, okay? So here's the thing, is we've got two lines, and here is this point right here. This would be the solution, right where they meet. And if we've got two lines and one point where they meet, then we would have one solution. And it will be an x value and a y value. It will be a point. Okay? If our two lines are parallel, meaning they're never going to meet, then we have zero solutions. No solution. And if our two equations happen to be the same line, they're identical lines, then we have infinite many solutions. That means that they meet at every single point along each of those lines. Okay, so there is a way algebraically that we could verify a solution. We would plug in our x and y that were given into each of these to see if they equal. So remember, this would be our x and this would be our y. So what do I mean by plugging it in? I've got x plus my y equals -6, and we want to see if that is true. So -6 and -4. So what I would do is I would come to my calculator and I would type in -2 plus -4 equals -6. Press enter. It says true. So that is definitely a point on this line. I would do the same. My pen clicks. Equals -2. I would do the same for the other equation, and I would type it in exactly like that. So 3 times -2 minus -4 equals -2. That one says true as well. So that means that this is the solution to this system of equations. So that's one way of verifying if we're given this solution. Most likely we're not given the solution. Most likely we're going to be given the systems of equations, either the graph of the two lines or just the equation of the two lines. It asks for the point. So we have to remember, again, like always, I just want to reiterate to make sure our equations are in slope-intercept form. Y equals mx plus b. And if x and y are on the same side of the equal sign, they are not. It's not in y equals mx plus b. We've got to get that y by itself. Our first step is always move your x to the other side by doing opposite operation. Remember, if one has an x and one doesn't have an x, you cannot combine them. Our next step is to always divide what's in front of y. So this is a negative sign, so it's like it's a -1. I gotta still divide that. So we got y equals 3x minus 6. That's how you get y by itself. Now it's in slope-intercept form. Now I can graph it. You've got to make sure they are all in slope-intercept form to make graphing easier. So if I'm given systems on a graph, I just need to look. Where do these two meet? Well, right here. So my solution is that point. Remember, we go to the x first, so 1, and then to the y. And that's it. It's really simple if you're given the graph, so that's -4, -4. You just need to make sure you know how to get the coordinates. That's 1, 4. 1, 4. We'll always go left and right first for that x value, and then up or down for the y value. Easy peasy like that, okay? If we're not given the graph, then we're going to have to graph them. And I've got our Inspire calculator steps here. So we want to go to New Document. We want to add a graph. If this doesn't pop up on your screen, we press menu 3, 1. So I'm going to type in, enter the first equation, x plus 3. They're both in slope-intercept, right? So we can go straight to graphing. I'm going to press the down arrow and go so I can enter in that second equation, 8x minus 4. Enter in second equation, and then I'm going to press enter. Okay. Then I can see right here, this is where they intersect. That point, this one we might be able to tell, but what I can do is go to menu 6. I want to analyze this graph, and I want the intersection. So I went to menu 6, 4. And I need to put this first dotted line, I'm going to click in the middle and put it on the left hand side, and then drag it, you see how it all turned gray, over to this other side. So we click to the left, and then we click to the right, and when I click on that to the right, it gives me that point, and it's hard to see because of where things are. That point is 1, 4. So my solution here is 1, 4. So let's do another example. New document. These are in slope-intercept form, so we can go straight to graphing them. So new document, add a graph. We got 3x minus 11, arrow down, 4x minus 17. Press enter. We can see this one's harder to see. So this is a great one where I can press menu 6, 4. I want to drag it to the left, and then drag it over here to the right hand side, and it brings me to my intersection of 6, 7. So my solution here is 6, 7. And we could go through this process to verify it if we wanted to.